Hi folks, my name is John O'Reilly. I live here in Galway in the west of Ireland, and I'm a software engineer and I work for a Norwegian company called Neat. And the plan for today is we're going to talk about the combination of Kotlin Multiplatform, GraphQL, and declared UI. So a pretty wide range of technologies. We're not obviously going to be able to go overly deep in each of these today. Hopefully, if nothing else, you'll get out of this maybe a flavor of what they are, the capabilities they provide, and what I think they are, compelling combination they are together. I'm going to give a couple of slides at the start just to give some context, a bit of overview, and then I'm going to jump into a live coding session where we build out a sort of very basic, again, kind of somewhat sort of space themed again, but a Star Wars, basically application Star Wars sample that I have for these talks, which is for relatively narrow in scope, but gives a good opportunity to sort of just demonstrate the moving parts and how they all fit together. So the first of these three technologies, I guess, is Kotlin Multiplatform. If you haven't come across it before, really at its core, it's about the ability to run Kotlin code natively on a range of platforms, on a pretty wide range of platforms. You know, it differs fundamentally from what you might call cross-platform frameworks, the likes of React Native and Flutter. It's typically focused on the sharing of non-UI code. You're left to use the best of breed technologies for your UI in terms of things like today with SwiftUI using Xcode, Jetpack Compose using Android Studio, and Kotlin Multiplatform then is focused on shared non-UI code. And that sort of gives it this capability. You hear people talk about this optionality, this optional code sharing that very importantly then allows, from a risk management perspective, allows this incremental adoption. You can sort of pull it in for a small piece of your shared code starting off, and that's typically the advice to do that. And then just sort of build up from there, then build up through the layers in terms of whatever makes sense for your particular project and company. And the other thing here is it allows, in the shared code, and we'll see an example of this, you're writing code that runs across these platforms, but there's still the capability then to access platform capabilities as needs be. So again, that kind of risk management element, that if you have to fall back to platform capabilities, you can do, and there's the ability to do that. This is a quote from Kevin Galligan from TouchLab. If you follow Kotlin Multiplatform at all, you're very familiar with these folks. It kind of captures a lot of these same points. I think it's a nice sort of succinct definition of Kotlin Multiplatform, and it has this point at the end that he kind of recently added in, which I think is very important, is that it's very much supported by JetBrains. It's something that they're very heavily invested in, and they're continuing to sort of build out the resources that they have dedicated to that. On that point earlier about KMM versus KMP, this is definitely a point that, when I started looking into Kotlin Multiplatform, so about 2 years ago, I guess it was KMP, Kotlin Multiplatform, and KMM is really more a rebranding really from JetBrains in the last, I guess, year maybe, or less. And it's sort of focused, I guess, on the key use case of sharing code on mobile, sharing code between Android and iOS, which is, clearly is sort of the dominant use case we're looking at in terms of sharing code between different platforms. But along with sort of, updated guidance and documentation, there's some more mobile focused samples, and there's also very nice, as we'll see in a moment, Android Studio and app code plugins that you can use for generating a Kotlin Multiplatform project from scratch. GraphQL, again, a hard one to describe in a single slide, and I'm hoping at least when we see examples of this later on, it'll become a little bit clearer. If you haven't used GraphQL, this is sort of this definition query language for your API. It's sort of hard to, I guess, kind of grok from that really exactly what that means. But as I said, we'll give some examples. There's obviously a server-side component to this, which is important, and part of what that server-side component supports is the ability to query for the schema of your content. So you get this ability then when you're using client libraries like we're going to be using today with Apollo to generate the code then, the strongly typed client code for your queries and the data model associated with that. And it's seen as being sort of more efficient than REST. I've seen somebody refer to it as sort of REST on steroids if you've used REST at all, in terms of it requires less requests, you define exactly what data you want to get back, particularly on mobile where you don't necessarily want to be making a lot of different requests. And GraphQL gives you support, not only in terms of just being able to sort of have a custom query that, maybe a single query to get your data back, but also specify specifically what data you want to get back in that, which is typically not the case with REST requests. And you see people talking about the ability to provide or to avoid what's called under and overfetching as a result of that. This is the library we're going to be using today, Apollo library. If you've used GraphQL at all, you're probably familiar with Apollo. It's been around for a while. There's a sort of an iOS library. There was traditionally an Android library, and as is often the case with Kotlin Multiplatform, the Android library, evolved into a Kotlin Multiplatform library, and it supports. It's defined as it's described as a strongly typed caching GraphQL client for the JVM, Android, and Kotlin Multiplatform. And the caching aspect of this is important as well, because what you get from this is not only just the ability to query your data, but also to cache it locally. So you get in effect this all-in-one solution, which is, I think, is very powerful, and even more so obviously when it's kind of deployed and used in shared code, then that's available across both Android and iOS. As a Kotlin library, obviously you've access to, and the APIs sort of support things like coroutines and flow. There's a very nice Gradle plugin, as we'll see in a moment, for downloading that schema I mentioned from the server, and also for generating the client code. And the V3 alpha, which is the multi-platform version, is recently added, as I said, support for the multi-platform cache, which is pretty interesting. This is, if you have used GraphQL, you may be familiar with sort of a UI like this. Typically, a GraphQL endpoint will support a kind of a web UI or a playground like this, which is pretty cool. Gives you the ability to sort of browse the schema, try out queries. What you can do, and what we'll see in a moment, is you can sort of tailor the query to exactly what you want, and then you sort of pull that into something like Android Studio, and then use likes of Apollo then to generate code from that. Declarative UI, I guess if you're involved in Android at all, you've obviously seen there's been a lot of discussion around Jetpack Compose in the last few months. SwiftUI, if you're an iOS developer, you're probably more familiar with maybe SwiftUI. Obviously, that's been around for a little bit longer, but both these are fundamentally very similar approaches. And the essence of what they are is, people talk about the what versus the how. Declarative UI frameworks like Compose and SwiftUI allow you to describe your UI in terms of what it should look like in a particular state. And state is very important in this context. The idea that any changes in state then cause the appropriate parts of your UI to be updated in sort of an optimal way. And that's sort of a lot of the heavy lifting that these frameworks do, as I said, is that they know what parts of the UI need to be updated. They can recognize when certain parts of your state have changed and update the appropriate parts of the UI, as I mentioned. This is sort of seen as contrast to, I guess, what you could say as the imperative style approaches of, the past, maybe, where this is more the how to create your UI step by step. And again, similar to the other points, I think if you haven't used Declarative UI, hopefully when you see it in action in a little while, it'll make a little bit more sense as well. A small bit of history. Jetpack Compose was announced at Google I/O in 2019. It was at a very early stage. It was really just sort of a concept really at that point. It got to stable release, I think July. Well, I have July here. It could be July or August. I can't remember exactly. But in the last couple of months, it got to stable release. SwiftUI was actually announced just a couple of weeks after I/O in 2019 at WWDC. It was at a much more advanced stage of development. It was available in the Xcode beta. That's sort of what got me interested in sort of declarative UI. I had sort of seen the announcement of Compose.io. It was very abstract at that stage. Didn't really see what it was about, to be honest. SwiftUI was available straight away to try out. And as an Android developer who had sort of struggled, I guess, getting iOS UIs together, struggling with, storyboards and view controls and so forth, SwiftUI was immediately, clear that this was a much more expressive, approachable approach to use. And I think this is the experience people are seeing now that we're starting to use Compose on Android, for example. The sample today is based on a sample from GitHub, Star Wars sample. The example in GitHub is a little bit more advanced. It shows the list of characters and the films. We're going to really focus on films today. I think I have an audience here that understands what film means as opposed to movie. So, but this is sort of a traditional. I think I'm not sure the history of this API. So, but they use the term film. So yes, it supports the ability to sort of query the API we're going to use, the GraphQL API we're going to use, supports the ability to query the list of films and characters, and say we're going to focus on films. So just before we dive into code, I just want to give people a flavor at this point. If you haven't seen Compose before, this is what a sort of Compose looks like. It's basically defined as a set of Kotlin functions, what are annotated with composable. And really what this is about is sort of, as I said, rendering. This is what your UI, the one at the bottom is if you think of your traditional Android application where you had a recycler view and an adapter and a view holder and layout files, this is what the equivalent would be in Compose. We have something at the bottom here which represents a row in our list, the film view, and this is it's rendering what it should display based on the state that's passed in. In this case, it's a film, and this film we're going to see in a moment is something coming from our shared code, Kotlin Multiplatform code. And then for the list, then we obviously, we're passing a list of films, we iterate over that, and we invoke the film view for that. The SwiftUI code then is very similar. We're using Swift. The syntax is going to be a little bit different. We're using structs as opposed to Kotlin functions. We have here the same sort of concept of a film or a film that's been passed in, the same concept of state. SwiftUI has this concept of sort of H stack and V stack, whereas in Compose it's row and column. both support text elements. The approach to styling is a little bit different, but still fundamentally, I think, one thing hopefully, again, if folks haven't seen these, that you'll get out of this is maybe that we're converging in a world where declarative UI is the dominant approach, on not just on mobile, but obviously on web with the likes of React and so forth. And how, certainly in mobile, how approachable this is if you're an iOS developer or an Android developer, how easily you can switch between these, I think. So I think that's a very interesting sort of, place we're coming to in the world of mobile development. This is the repository that I mentioned, the Star Wars repo. There's also, I have, if you look at my GitHub, I have 7 or 8 sort of different samples that are sort of Kotlin platform focused. They exercise a range of different Kotlin multi-platform libraries. More to Compose is another one that uses GraphQL. It takes a little bit more advanced UI. It utilizes sort of the paging support that GraphQL provides and sort of hooks that up with the very nice paging support that Compose provides. So again, if this is something that's of interest to you, obviously you're very welcome to pull these down and try them out afterwards. This is a very high level diagram of what an application like this might look like, just to kind of at least give folks sort of an idea of sort of the key moving parts here. Our Kotlin multi-platform shared code, in our case, we're going to build up a very basic repository that sort of encapsulates our interaction with our GraphQL server, has a sort of data model associated with it. We're not actually even going to use view models today. In most of the examples I have in the repository use view models, but this is the thing about Kotlin multi-platform. It doesn't force you to use a particular architecture. You're free to use whatever makes sense. As I said, in the share code, we have a repository. If you're using something like clean code, you might have your use case interactor there. I tend to favor using the view model within the platform code. Some people will put the view model into the share code as well. So again, there's a range of options supported when you use Kotlin multi-platform. And again, that's kind of that optionality comes into play as well. That's sort of that ability to incrementally adopt it and to sort of tailor it to what makes sense for your particular application. Okay, let's write some code. So what I'm going to, so the way to, if you're starting out doing Kotlin multi-platform today, the first thing that, if there's anything you get from this talk is don't try and create a Kotlin multi-platform project from scratch. There's a sort of, it can be challenging. I see a lot of questions in sort of Slack and Kotlin Lang in terms of people tripping up on different sort of Gradle configuration. There's a very nice plugin, like I mentioned earlier, that allows you to create a new Kotlin multi-platform project for iOS and Android. I have a range of samples. The likes of TouchLab, who I mentioned earlier, have some nice ones as well. So definitely recommend that. The nice thing about some of the samples, for example, is that there's a range of samples available that use a range of libraries. So depending on the type of application you're developing and then maybe the libraries you're looking to use, then you can pull in a sample and maybe tailor that. But as I said, there is this Kotlin multi-platform plugin available, which is quite nice. It's available for Android Studio and Appcode. And this gives you the ability to create a new project. Typically in a project like this, as we'll see in a moment, you'll have your Android, you have a number of different modules. You'll have a module for your Android application. You'll have a module for your shared code, and then you'll have a iOS application. And what this supports as well, and I'll touch on this in a little while, is sort of setting up the plumbing. So what we fundamentally want to do here is that our shared code on Android is going to be built as a jar file that is just a normal Android library jar file that's going to be consumed by your application. In the case of iOS, our shared code is going to be built typically as a framework. And these different plumbing options basically set up how Xcode delegates down to build the appropriate framework and pull that into the Xcode project. And there's a range of different options available. As I said here, this sort of regular framework, which we're using today, are CocoaPods. And depending on your particular project, what makes sense. There's also a range of other options. These are sort of based fundamentally on the idea that you're building from source code, that as your iOS and Android developer has access to the source code, to the source of the code of the shared module, and is building it and able to make changes. There are other approaches available as well if you take more approach where you want the shared code to be published as a binary using something like a Swift package, for example. Okay, so this is a sort of, I guess, something prepared earlier a little bit. We have a project that we, sort of sample project like this. We have our Android application. We have, we're not going to talk about that in a moment. We have our shared code, importantly, in the context of Kotlin multi-platform, and we have an iOS application. And in our shared code, we're going to create a simple repository, and we're going to access that repository then in Compose, and then we're going to switch over to Xcode and use that from our SwiftUI code. So a couple of things before we start writing the repository. So we're using GraphQL, as I mentioned. One of the things, if I just jump quickly into the Gradle file for our shared module, you can see we're using a GraphQL plugin. We're also obviously using a multi-platform plugin. We're targeting Android, iOS, and JVM. I'll talk about the JVM in a moment. And what we typically have in an environment like this is, in our shared code, is that we have a couple of source sets. And the key one is the common main. This is where all our shared code is going to reside. And in our example today, all our code is going to be in common main. But there is a capability then, you'll see an Android main and an iOS main. In certain situations, you want to sort of override, you want to provide platform-specific capabilities. If you were doing a traditional sort of REST API with sort of local persistence, you might use a library like SQLite, for example, which is a multi-platform library. And then in that case, for example, you'll need to define, or you need to create an Android-specific and iOS-specific database that's used. And this is where the sort of Kotlin multi-platform capability, this kind of expect actual capability that they provide, allows you to do that, which is very nice. So as I said, I touched on that on the slide earlier. You're free to write, you're targeting as much code as possible that's shared and runs on platforms, but you have the ability to sort of to use platform-specific capabilities as the need arises. Okay, so having created this, we're going to the first thing we're going to do here is we're going to download the schema. I mentioned part of what you get with GraphQL is that you have these backends. The GraphQL server supports the ability to query the schema for the content that you're going to work with. So we're going to run this Gradle task here. And what this is going to do is going to use Apollo's this download Apollo schema task to sort of pull that down. And sort of, as you can see, this is what, obviously we had done this previously, but this is sort of what you get back from that. It's a sort of JSON that defines the schema for the data that you're dealing with. And what we're going to do, what Apollo do then, will generate source code associated with that. But the other thing that we want then is a set of queries. And what we would typically do, so this is where I'm just going to tab over to, I mentioned that these GraphQL backends typically support this kind of playground web UI, and this is a very nice feature that, in working with GraphQL, it's a very nice feature, I think, of the environment. You can browse through the schema, you can browse through the queries that are supported, you can tailor your query exactly as you want. So in this case here, let me just run this here. We're going to get back the list of films, and for each film, GraphQL has a concept of fragments, which is sort of an ability to sort of pull out sort of part of our data that we're getting back into sort of a reusable chunk. And we'll see in a moment that gets generated into a Kotlin data class, for example, representing that. But we have full control over, in this case here, we're just getting back our ID, title, and director. Later on, we'll add some additional data to sort of tailor our query a little bit more. But having done that, then we can sort of pull that query into a query file that Apollo is going to generate code from. Another nice thing to sort of highlight here is that Android Studio has a nice GraphQL plugin as well, so we can actually run our query directly from Android Studio as well, which is quite nice. And you can see that we get back the same data that we got back in that. So it gives you sort of an extra level of sort of sanity testing that your query is correct, that it's correctly formed, and you're getting back the data you expect. So having done that, then we can run the generated Apollo source. Now this is something that will be run automatically as part of your build, but I'm going to run it explicitly here because I just want to sort of just give me an opportunity to show something in a while. And this generates source code for making the queries for the particular query classes, and we'll see that in a moment, and the data model associated with the schema that we're working with. So now let's start building out our repository here. So I'm going to save you watching me mistype a lot of code, I'm going to make a lot of use of Android Studio live template, or live templates, and in the case of Xcode, code snippets. I'm going to sort of pull in small blocks of code like that, and use them as a sort of a segue to explain certain things as I'm doing that. So we'll start with our film model. So this is the sum total of our data model that we have in our shared code, that we're going to have something representing a film with an idea, title, and a director. In the query earlier, we had this concept of film fragment, and that's going to map over to a data class that's generated by Apollo. So we're going to use this film fragment here. We're going to add an extension method to map. Just what you do in your own particular application may vary. It's generally seen as a good practice to sort of map the data model between from what we're getting from perhaps something like GraphQL to what we're exposing from our shared code. You don't necessarily have to do that, but in this case here, we just add an extension function to film fragment. And if we go into film fragment, then we can see an example of this. This is sort of this is code that was Apollo generated from that query that we wrote and the associated schema. And you can see, for example, it pulls over the comments as well, which is quite nice. Okay, so let's start building out our repository. We have a basic repository here. We're going to create an Apollo client object, which is the key object you deal with from the Apollo library. Passing in the server URL, which is this endpoint here, which is the endpoint obviously we're dealing with. I have, as I sort of commented out here, I'm a little bit paranoid in these talks that an endpoint like this won't be available. So there is actually in these samples, there's a sort of backend module that allows me sort of using Ktor to basically run a sort of a simulation of the backend. So if for whatever reason the endpoint isn't available, then we can point to sort of a local host and we can run it against that. But the key thing here is we have this Apollo client object, and we have we're passing in the endpoint that we're using. Now let's add a method. This is sort of in this very complex application we're developing. This is pretty much the sum total of sort of the API surface from our repository. We have a suspend function here, which is returning the list of films. We're using Apollo client. We're using this get all films query, which was a class that was generated from the query code by Apollo. And with the response then, we're navigating down. I mean, what we're seeing here is a little bit of sort of plumbing. We won't go into too much detail, but again, if we look at our query, you can see we have in our response, we have all film fragment. And what you'll see here, for example, is something similar. We have all films, and then obviously we're mapping then from the data we're getting back from Apollo into our data model that we're exposing from the shared code. Now, before I do that, I'm just going to add one other thing, which is we're going to add a version of this method that we're going to call from iOS. Now, this is a big topic in itself, but just to mention a couple of things, you can actually, the capability was added in Kotlin 1.4 to call suspend functions directly from your Objective-C Swift code. It comes with some caveats in terms of the scope that's used and the ability to cancel and so forth. I guess the traditional approach that we're going to use today that would have been used before that is you write another version of the method here where you pass in a lambda or a closure. We use some kind of associated scope that we're going to use for these calls, and then we launch the scope and we call the suspend function of this method here. As I said, a range of options available here. There's some nice community developed libraries that are emerging. There's a KMP coroutines one that provides the ability to, in a much more structured way, to sort of map between sort of async libraries in the sort of iOS world to Android, for example. Something like a suspend function is relatively straightforward, but then when you start to use Kotlin flows, for example, how do you map those over? How do you manage cancellation? How do you couple the cancellation to the lifecycle of your UI, for example? So there's a number of libraries being developed that allow you to do things like map from the Kotlin flow in your shared code over to something like a Swift combined publisher, or with the Swift 5.5, some of the new async capabilities there with async await and so forth, which is very interesting. But in our case, like I said, we're going to have a simple method here where we pass in. We're skimping obviously a little bit on error checking here as well, but you would potentially pass in an error handler here as well. So before we jump into the client code, just one other thing to point out. I had sort of touched on earlier that in our build file for our shared code, we have an Android, iOS, and we have a JVM target. And the JVM target is a nice thing to add in general, because what it gives you is the ability to do something like this. Even just as a sanity check, I can have a main function here in my JVM code, which is exercising the sort of repository class that I created, get back the list of films and just print those out. So let me just run that here. And just sort of, as I said, just gives me a bit of sanity that things are sort of hooked up correctly. And good. And that's returning the list of films that we're getting back from the endpoint. Okay, so we're set up at this point now. We have this, as I said, not particularly overly sophisticated shared code here with a simple repository with a method to get back the list of films. We're going to jump into some Jetpack compose code, and then I'm going to switch over and do some SwiftUI code then after that. Again, just for ease of illustration, and similar, in a similar way to the repository that we kept all that code in a single class there. I'm going to keep all my composables in this file here. What you do in reality, obviously, in terms of splitting that up, is going to be a little bit different, but compose is fundamentally about sort of a hierarchy of sort of composable functions, and we're going to sort of start down at the sort of the leaf node of that, and we're going to add in something that represents the row in our table, row in our list. This is the film view. We saw an example of this in the slide earlier. We're passing the film. This is the film class that comes from our share code, and we're saying what is the UI that should be shown based on that state, and we're just going to show a simple list item with the text and secondary text, the film title and the film director, for example. Add some appropriate styling to that. We're going to go up the hierarchy a little bit more. And we're going to add something representing our list. And again, I made that comparison earlier between sort of, in the Android world with recycler views and adapters and view holders and so forth. This is the equivalent you have today. And I think this is one of the nice, things. If you're looking at an example of how expressive composes compared to the traditional Android development, I think this is a nice example. Our code is one place. We don't have this sort of somewhat false separation of concerns I think we would have had before with XML layouts and our sort of our view code. Everything is in a single, is in Kotlin like this. We're going to go up one more on the hierarchy and add something that represents our sort of screen as a whole. This main layout class. We'll make some changes to this in a moment, but for the moment, it's just delegating down. It's calling film list. But we're starting to pull in a couple of, I guess, compose capabilities here. One of the things about compose is these functions are invoked by the compose runtime. We don't have control. They can be invoked at any time based on compose's particular algorithm in terms of what it sees as the optimal way to lay out these out based on state changes it detects. So one of the things we want to do in a case like this, for example, is we're going to use our Star Wars repository from our share code, but we only want to create it the first time the UI is composed. We want it to obviously be created every time this is called. So we're using compose's remember for that. I mentioned you may use a view model. You know, a common scenario here is maybe a view model exposing something like a mutable state or state flow, for example, and compose comes with a nice set of extension functions to map those then to what is its concept of state. So compose has its own concept of state that drives it's how it renders the UI. Speaking of which, then we're going to use another extension function from compose called produce state, which allows us, it gives us this implicit coroutine scope that we can call the suspend function from our repository. And then the value that's returned then is stored in film list in that state. And then what compose will do for us, you know, this is what you get for free with compose, is that it will detect any changes to that state. When the film list is updated, it will re-render what parts of the UI reference that state and need to be updated according to this. With an example like this where we're calling suspend functions, maybe it's not as apparent. I have examples where we're using flow, for example, and as data comes back, it detects that the state has changed and it updates the appropriate UI. And you can start to see here, I think, the contrast obviously to the imperative approach, where you would have to take a much more step-by-step approach to sort of managing those updates. Okay, and lastly, we're going to have something at the top level representing our overall activity. You'll typically have a single activity in your application. Instead of calling set content with an XML layout like you would have in the past, we're using Compose's extension function set content, where we're just calling into a suspend function. And we're using Compose comes out of the box with very nice sort of material theming built in. If you create a new Compose function or Compose project, you'll get a default theme that you can customize in terms of your own colors and typography and so forth. And in this case here with the Star Wars theme that wraps around that. And that implicitly gives us access then down in the composables, as we did earlier, as we did down here, into sort of, you know, typography, different elements of typography and so forth. So very well thought out. Obviously, you know, this becomes obviously very apparent from, you know, when you start to use Compose, just how much, you know, 10 years of the view system on Android and how all the lessons that were learned from that sort of fed into the design of the system, which I think is very nice. Okay, let's try and run this. And yeah, just while it's running that, so okay, it was a little bit faster than I expected. You know, what's happening under the hood, obviously, in this case for Android, it's very basic. Our share code is being created as a jar file, which is being consumed on the Android app module. And if we just minimize this for a moment, you'll see this very sophisticated UI that we have, which we'll build it out a little bit more. It'll look a little bit nicer in a while, but it shows the list of data, you know, and at least at this point, you know, we've set in place really the key moving parts here. We have shared code, we're using Apollo, we're making a query to backend, that data is being cached locally, we're returning that into Compose. Any changes in that state then are causing Compose to relay out this UI and so forth. But let's build it out a little bit more, maybe just instead of just the film list here, we'll use Compose's scaffold. Remember, so scaffold is Compose's, so I guess something representing the screen as a whole. In this case here, we're adding a top app bar. The example in the GitHub also has a bottom navigation, for example. It's all very common, typical scenario in Android where you have an app bar and a bottom navigation. So here we have a scaffold, a top app bar, and then we're evoking film list in that case. Okay, our UI looks a little bit better. We have a title bar here, and when we update the GraphQL a little bit later, we'll add a little bit more to that. But before we do that, let's switch over to iOS. So I have Xcode project open here. This would be the example of an Xcode project you would have got for free, so to speak, when you use something like the Kotlin Multiplatform plugin to generate your project. As I mentioned, there's a range of different approaches that are used to sort of what we want fundamentally here is that when I build an Xcode, I wanted to delegate out to run that Gradle task to build the shared code. In this case here is a framework, and to recognize obviously when code has changed in the shared code, to rebuild the framework, and obviously some plumbing to sort of pull that into our iOS framework. And if you look, for example, in a project like this that's generated, you see that there's a run script, and in this run script here, this is added to it, like where we're using. This is something that comes from the Kotlin Multiplatform plugin. This built-in task that will do that for you. That will run the will generate the framework from the shared code. And you know what it's going to do here. Actually, let me start building this out first of all before I mention that. So here we have you know, something very analogous to what we had in Compose. We have a film view, you know, representing, and again, these are the examples from slides earlier. We have something representing the row in the list. We have the list itself. We have something representing our screen as a whole. The approach to navigation in SwiftUI is a little bit different. How we do a top app bar is obviously going to be different. The hooks we use to sort of, we're calling our repository class here, and this is the repository class from our shared code. We're dealing with films here, and these are, again, this is the data model coming from our shared code that we're using here in iOS as well. So some differences here, but hopefully what you see, you know, is a very similar approach to what we were using in Compose. So let me run that. And while I'm running that, then I guess, yeah, that sort of segue to mention, the first time you run something like this within Xcode, it's going to delegate out, run the Gradle task, and build a framework. As a iOS UI developer, you know, who's maybe iterating on the UI, subsequent runs of that then are going to be pretty fast. Going to quick turnaround is going to see that nothing has changed. So from a sort of what you might call developer ergonomics, they have the shared code, it provides this capability, and then as an iOS UI developer who's really sort of focused on building out sort of this compelling user experience, they can focus on the UI then and just have these capabilities that they're pulling in from the shared code. And this is the same data then we're getting back from that we were showing on Android, obviously, and that we're showing on iOS as well. So let's go back and make a couple of changes, or at least one main other change. I mentioned that a key thing with GraphQL is the ability to sort of tailor your queries. And right now we're showing ID, we're showing title and director right now. So if I go back to this sort of playground UI that I mentioned earlier, very nice UI here that allows me to sort of browse through my schema and have autocomplete. So we might want to add something like a release date, for example. So we get the autocomplete as part of that. We can run the query here. We can see, yeah, okay, that's the release date here. Go back to Android Studio. Let me just copy just to avoid any mistyping. We'll add that to our query here. If we're being paranoid, we can run that here as well. Just confirm that we're getting back the release date. Let's jump into Gradle for a moment. And again, just I'm going to run this. Again, this will be run automatically as part of your build, but I'm just going to call generate Apollo sources directly, just so that we can see the updated generated code from this. And now if I go into Star Wars repository and I go into the film fragment, we'll see that there's a release date added here that was generated from the schema code. And again, it pulls in the comment again, which is quite nice. So now in our repository class, we can, the only code I think that you're going to have to watch me type, release date. I'm probably going to mistype it. String. And then in our extension function, obviously, then we're going to have release date. Okay. Did I spell that right? I think I put two. This is the reason why I shouldn't be typing here. Okay. So now our data coming back from our shared code includes the release date. So now we can go into our Jetpack Compose code. Instead of film title here, I'm going to add, I'm going to use my code snippets again. We're going to show the title and the release date. If I go back to my Android app module and run that. You see the release date coming back and showing in the UI. So again, a very basic example, but hopefully kind of demonstrates sort of the key moving parts here. Let me sort of just recap a little bit, just sort of put some of these things in context again. We have a project here that we've created, Kotlin Multiplatform project. It has a shared code module, in this case here with a single repository. This code is going to be running shared on both Android and iOS. It's going to generate a jar file for Android, framework for iOS. In our repository, in our shared code, we're using Apollo client library, which is going to take the the queries that we want to use and the schema associated with the GraphQL backend that we're using. And it's going to generate strongly typed client code that we can utilize in our queries here. And that data then is returned into, it's available then in the code that uses that repository. In our case here, we have some Jetpack compose code that's going to show a simple list. It's interacting with the shared code as you would in a sort of a normal case where you had, a library, a Kotlin library. In the case of iOS, we have something very similar. We're using SwiftUI here, of course, but we've imported our shared module. This is something representing the framework that was built from the shared code. And then we have access to the full API exposed from there. And we're writing Swift here. Just a small point I suppose to add here is that the code that's actually generated is Objective-C code. And then that's available under the hood then from the Swift code here. There is sort of in the roadmap of Kotlin Multiplatform the support for generating Swift directly. And in our case here, then we have access to the shared code. We're using the Star Wars repository. This is the same Star Wars repository we used in the compose code. We're accessing film class, again, the same shared code. Again, the same concept that any changes, any updates, whenever this film list is updates here, the UI in the case of SwiftUI is re-rendered. I'm just going to show you one other thing, sort of again, in the context of pre-prepared code. What I would typically do in cases like this is I would use a view model. You can have that view model in your shared code, or you can write it in sort of an Android architecture component, and then something like this in the SwiftUI world. This is something very analogous to the Android architecture component. I mean, what you fundamentally want is something that has sort of lifecycle awareness and sort of the ability to observe data. Here we have Swift using sort of Swift combine this observable object, calling into get films, and any updates to the film then it sort of updates this film list, which is published. And again, that's concept of state and observability, and any changes to that state causing the UI to be re-rendered. So again, that same fundamental approach being used. I believe that's it. I'll share slides later. A couple of links, obviously. My Twitter handles there. You're very welcome, mostly, to reach out to me. Obviously, opportunity for questions down in a moment. Some samples there, either through my Twitter handle. You'll see a link to the GitHub repo, and there's a range of Kotlin multi-platform samples there that, as I said, exercise a range of different multi-platform libraries. Thank you.
Excellent. Thank you, John. Really appreciate that. If anybody has any questions, please feel free to add them to the chat. But to kick us off, you mentioned that you tend to put the kind of view in the actual view in the specific code for the platform you're building for. Is there a general rule of thumb that you follow to determine what to put in shared code, what to put in other code?
Yeah, it's a big topic in itself. There's I guess come at it from a couple of angles, I suppose. First of all, I suppose as a general point, one of the very nice things about Kotlin Multiplatform is it gives you complete freedom to share whichever amount of code you want to use. And the typical advice is to start off small, put it in for something, maybe like some shared analytics code, and maybe build up to some sort of persistence, remote API requests like this, maybe use case interaction. There are libraries, for example, there's a company called Moco that provide a kind of Moco MVVM sort of ability to sort of define a view model in your shared code. I've sort of, maybe this is sort of maybe I'm biased from my experience a little bit. I've kind of grown up, so to speak, in terms of the Android architecture components and the view model and a lot of sort of value add that provides. And I still think on an Android, for example, that continues to provide a value in terms of the lifecycle awareness and sort of implicit view model scope you get with that. And when you use, I typically use something like Coin for dependency injection, but regardless of what you used, the ability to sort of hook into saved instance state. And if you look at some of the navigation capabilities being pulled out for Compose, some of them are really sort of still built based on the idea of using the Android architecture component version of the view model. But there's ways around that, and some people are obviously doing that successfully. In the iOS world, then you get into sort of another sort of discussion there to some extent, as there's, I suppose, stepping back for a moment, I think if you talk about, I guess, and you ask, so what are the challenges with Kotlin Multiplatform? Most common answer typically is how do you persuade, how do you sort of convince an iOS developer to start adopting it? And that's an understandable one. The iOS world is typically been a kind of a walled garden environment where Apple provides pretty much everything you need, and you don't typically need it. In the Android world, we're used to sort of using open source frameworks and using different libraries. So we're a different environment in Apple, as folks know. Hopefully the focus that this is on non-UI code, and I sometimes see people talking, like Kevin Galligan I mentioned earlier, sometimes describes it as, if you're trying to persuade iOS developers, what parts of the application do they not like working with? Some of the core data interaction, for example. Analytics is a common one. So, build up from that, build into some sort of shared code for some piece of shared logic that you're using on your mobile clients, and an iOS developer can very easily pull into their project. They continue to use Xcode, they continue to use, SwiftUI, combine, and then they have this additional capability that just becomes transparently available to them to some extent, through this framework that's exported, or if you're using Swift package, for example. As you go up the stack, then I think you start to encroach a little bit on sort of what I think for many people, for a lot of iOS developers, they feel it would continue to be their territory, I think, where they would feel like they're under control. And this depends a little bit on the context of, of the type of project, the type of environment, the type of company you're in. I worked in a previous company, where we had, I think, 60, 70 mobile developers spread all over the world. The release cycles didn't necessarily always match up. So, there's an element of pragmatism, reality that needs to kick in a little bit in terms of you need to maintain some degree of freedom on the different platforms. In many cases, if you're a 2 or 3 person startup and you're working together to build this out, then you have a much wider range of possibilities in terms of how much you can share and how much you can define. But I still feel that, certainly in iOS, I think having that additional degree of freedom and having the view model in the iOS project, I think it doesn't add a ton of additional complexity, and I think you get a lot of benefits from that. But it's one of these cases where opinions differ, so that's just my opinion.
Awesome, excellent. You mentioned, is it frameworks? Is that what pulls into iOS, into Xcode?
Yeah. So basically, it's a sort of binary that gets built and pulled in. There's different. It's kind of evolving space. There's this concept of XC frameworks, and there's what's getting popular is the idea of sort of Swift packages. I have some examples, for example, where you can, again, sort of taking a different approach. I mentioned in terms of the idea that in an ideal world, there'd be shared ownership of the shared code, and that as an iOS developer, an Android developer, I can go in and change the code. And this is the other thing, I guess. I talked about a little bit this kind of mobile convergence a little bit when you think about SwiftUI and Jetpack Compose being very similar. We'd got to a point already, I guess, to some extent, with Swift and Kotlin being very similar to each other as well. If I go back several years to where we were using Objective-C and Java, for example, obviously it wasn't the case. With Swift and Kotlin being very similar, I think it's a lot more approachable as an iOS developer going into Kotlin code and making changes, particularly making non-UI code that by definition typically don't have platform dependencies, some level of business logic or analytics code, for example. But there is even within the same team or in some environments, I do think it can make sense that the shared code is created as a binary that's then consumed. So you can publish that. You can publish that as a Swift package, for example, and you can go into Xcode and you can do something like, if I can remember where it is here, you can package. Yeah, you can point to a GitHub repository, for example, and you can pull down your shared code as a Swift package. And that makes it even more seamless, I think, as an iOS developer, that I have this capability available to me and I can just pull it in. It's like an API, like any other API I'm using. I'm still focused on developing this user experience, and I have this API that provides this capability of this non-UI logic that's available to me. Long-winded answer.
No, that's awesome. Thank you. I mean, I don't do mobile development, so I don't really know much about it, to be honest with you. But is there a specific kind of architecture that you follow generally for these apps? Is it kind of are the standard patterns that you follow?
Yeah, and I think it's one that the industry in general has been converging on anyway. It's kind of MVVM. I think there's a range of I see somebody popped in the chat there, MVVM. I was at a DroidCon in London, I think about 5 or 6 years ago, and there was this religious debate about MVP versus MVM versus whatever. I think for the most part, MVVM, you'll hear people talk about MVI, model view intent, and I see that more as a variation, a specialization of MVVM, to be honest. But I mean, what you're getting in the environment that what the likes of Compose and SwiftUI is encouraging is what some people describe as unidirectional data flow. And then you get patterns like MVI, which sort of structure it around that a little bit more, but they're still fundamentally based on the same idea, I think. And the MVI implementations are still based around sort of using the Android architecture, Android view model, and using something similar in that. So I guess just to kind of summarize a little bit, I think using Kotlin Multiplatform doesn't necessarily force you to use a particular architecture. I think in using sort of declarative frameworks, we're coming toward, or we're converging towards, I think, MVB and MBI type approaches.
Excellent. Thank you very much. Just one final question. What kind of dog do you have?
Yeah, she came up and made a little noise and disappeared again. She's kind of a cross. She was an abandoned dog that we got a long time ago. She was, I think she's a cross between like a collie and a sheepdog or something. So yeah, she keeps. That's nice when you're working from home. It's nice to have the company of a dog beside you.
I agree totally. Thank you very much for that, John. I really appreciate that. It's great to see some live coding again as well. If there's any other questions, please feel free to kind of post them in the chat. John, if you're hanging around for a bit, then
I'll be hanging around, and feel free to reach out to me if you have any questions as well.